Hi friends, this is Sayukta from Mathsgenii. Today we're going to talk about the chapter Trigonometry. Even before starting the chapter, I would like to tell you this comes from two Greek words, combination of two Greek words. The first word trigonon meaning triangle and the second word meaning metron means measurement. So trigonometry is nothing but measurement of triangle. Now let's look at the usage. In your textbook, you find examples typically like finding the height of the tree, finding the height of the building, or finding the width of the river. In real life application, you use it in Google Maps. Yes, the same application you use to find any location. You use trigonometry in Google Maps as well. Wasn't it fascinating and surprising? Also, Pythagoras theorem is applicable for triangles which have 90 degrees and where we know the measure of at least two sides. Okay. Now, what is the formula, students, for Pythagoras theorem? This is 90 degree. Formula is side 1 square plus side 2 square is equal to hypotenuse square. Let's just apply this formula here. Side hypotenuse is what, students? Side opposite to 90 degree. So this is hypotenuse. Side opposite to 90 degree. So this is hypotenuse. Okay. Now what is the formula? Side 1 square, which is this, plus side 2 square, which is this, is equal to hypotenuse square. Okay. 3 square is 9. 4 square is 16 is equal to hypotenuse square. 16 plus 9, 25. Hypotenuse is what? C square. Now when I send this square on this side, what does 25 root become? It becomes 5. So your third side is 5. So when do you use Pythagoras theorem? When two sides are given. See, in this case, A and B was given in the question. I found out C using the formula. Now let's look at another version of the same question. What is the formula, students? Side 1 square, which is 8 square, plus side 2 square, which is B square, is equal to hypotenuse square, which is 10 square. 8 square is 64 plus B square. 10 square is 100. B square is equal to 100 minus 64. B square is equal to 36. Therefore, B is equal to 6. Square that side becomes square root. Therefore, B is equal to 6. So, my only objective of revising Pythagoras theorem is you use Pythagoras theorem when two sides are given. But in life, in all the questions, you will not get two sides. Sometimes you will get an angle and you will get only one side. Sometimes they will give you a measure of angle and they will give you only one side. In that case, what will you do? That is what we are going to learn in the chapter Trigonometry. Now, I have given you two questions. What to do when only one side is given in the question? What to do when angle and one side is given in the question? That is why we are going to study trigonometry. Now, in trigonometry, you have to remember the way I have written on the screen and you will never forget it in your life. So, there are 6 angles in the trigonometry that we consider, which is sine, cos, tan, cot, sec, cosec. Clear? Now, let's look at the theta. Suppose this is A, this is B, and this is C. So, it is applicable in these type of triangle. Now, I will tell you a formula of how to remember it. You remember I had taught you opposite, hypotenuse and adjacent. Three type of sides. Similarly, we're going to use those sides only. Remember what I had taught you? Hypotenuse is side opposite to 90 degree. Suppose this is my theta. So side opposite to theta is opposite side and the remaining side is adjacent. Now how to remember the formula? Pay careful attention on the song or the rhyme that I am going to say. O H A H O A. Repeat after me. O H A H O A. O H A H O A. O H A H O A. Now you will always remember this in this way. Also remember the sequence. Sine, cos, tan, cot, sec, cosec. Always go in this sequence. So in this sequence what happens is you can easily reverse. Here you have O upon A. So here you will have A upon O. Similarly reverse of this. A upon H, reverse H upon A. O upon H, reverse H upon O. So these are the 6 types that you're going to remember. Sine, cos, tan, cot, sec, cosec. And the song is OHAHOA. OHAHOA. Now always remember this in the form of a rhyme. Okay. Now let's look at a question which is going to make it a lot clear for you on how to solve. Okay. In a right angle triangle, he says ABC is the name of the right angle triangle. So let's draw the right angle triangle and let's name it as ABC. Now the next information in the question he is giving, right angled at B. So I drew a box of right angle. AB is 24. Okay. BC is 7. Okay. He has not given me this side. I can easily find out this side using what, students? Using Pythagoras Theorem. Okay. Now let's look at the formula of Pythagoras Theorem is side 1 square plus side 2 square is equal to hypotenuse, side opposite to 90 degree. So AC square. If you solve this, if you add these squares, you get 625 is equal to AC square. AC is equal to 25. Wow, now I have all the measurements that I need. Now he is asking me sine A. Sine A. Now you remember what was the song? OHAHOA. What comes first in the song? Sine. So sine's formula is OH. Sine's formula is O upon H. Now sine A. So this is my target. What is the opposite side of sine A? Of course it is this, which is BC. Upon what is hypotenuse? Hypotenuse is side opposite to 90 degree. Hypotenuse is AC. So BC value is 7 and AC value is 25. So with the help of OH, I found out sine A. Next in the question, he is asking me to find cos of A. Very simple. Again, remember the rhyme. OH, AH, OA. OH is already done. OH, AH. So, if this is O, if this is H, then what I have taught you, remaining side is A. So, A is 24 and H is 25. So, for angle A, You are sorted. Now, let's draw this triangle again. You will understand why I am going to draw this triangle again as we go in the very next step. So now I have redrawn the triangle. I'll just write the values again. I have redrawn the triangle and now I'm writing the values. So in the question, now he is asking me the value for this is solved. Now he is asking me value of sine C and cos C. So C is the hero in this question. So let me write theta here because he is asking me about C. This is 90 degree of course. Side opposite to 90 degree is H. Side opposite to theta is opposite O and remaining side is A. First part we did for sine A. Now we are doing it for sine C. Again the formula remains the same. OH. What is O? 24. What is H? 25. Now cos C he is asking me. Cos C formula OH AH. So AH. A is 7 and H is 25. Okay. Now this is how you solve using the formula OH, AH, OA. Now I would like to show you a complex problem so that you will remember it always. Okay, let's look at this problem. And I would really appreciate if you pause the screen and go back to the formula where I have written about OH, AH, OA. Now, if you look at this question, he has given me a triangle. Okay, let me just name it as ABC. Okay, now if you remember the formula sheet that I had written, I will again write it. Sine, cos, I'll quickly write it. Tan, cot, sec, cosec, right? This was the formula. Now what was the rhyme? OH, AH, OA. Reverse this side. A upon H becomes H upon A and H upon O. So he is telling me I have given you sec theta. Now you find sine, cos, tan, cot, cosec. I have given you a one value. You give me all other values. The question is that. Now he is given me sec theta. What is the formula of sec theta? This. So let me just write sec theta is equal to H upon A. And what he has given is 13 upon 12. So H in this figure, H is what? Sine opposite to 90 degree. So H is 13. I am very clear on that. Now let me take this as theta. So this is O, side opposite to theta is O, and this is A, remaining side. So H is 13 and remaining side A is 12. So I know this is 12, I know this is 13. Can I find the remaining side? Of course. What is the formula? Side 1 square, Pythagoras Theorem, plus side 2 square, which is BC square, is equal to hypotenuse square. Therefore, BC square is equal to 13 square minus 12 square. 13 square minus 12 square. 169 minus 144, which will give me 25. BC square is equal to 25. BC is equal to 5. Great. Now I have the measures of all the sides. So this was my rough work to find the third side. And how did I understand what is H, what is A? He had given me only sec theta. What did I do? I compared it with the formula, which I already knew. I knew the formula is H upon A. So I compared. H is 13 and A is 12. I wrote it in the diagram. Now what he is telling me? Now we will write what we have got. We have got O, we have got H, and we have got A also. What is the value of H? We have got 13. What is A? 12. And what is, okay, what is H? H, if you look at the question, H is 13, A is 12, and BC, which was O, is 5. So we have 5, 13 and 12. And we also have all the formula in front of us. What is sine? O upon H. O upon H. What is cos? A upon H. What is tan? O upon A. OH, AH, OA. Now how have I taught you? Below tan, always cot. Sine, cos, tan, cot, sec, cosec. So when you find first three, the next three automatically comes. 5 upon 12 is tan, so cot will be reverse of it. 12 upon 5. If cos is 12 upon 13, sec will be 13 upon 12. If sine is 5 upon 13, reverse of sine is cosec. So reverse of 5 upon 13 is 13 upon 5. Very simple, very important are other kind of ratios. We just saw some of the examples wherein I told you that you have sine, cos, tan, cot, sec, cosec. So you have these basic ratios, right? So I told you that sine is the reverse of cosec, cos is reverse of sec, and tan is reverse of cot. I had told you this, right? But there are other formula also which you need to know. Very simple ones. Tan theta is equal to sine theta upon cos theta. I'll explain it with example. Example, sine theta was 5 upon 4 and cos theta was 2 upon 3. And he asked me to find tan theta. How will I find tan theta? Tan theta is sine upon cos. Sine is 5 upon 4. Upon cos, cos is 2 upon 3. How will I solve this? 5 upon 4. This division sign, when I have to convert in multiplication, 2 upon 3 becomes 3 upon 2. When you convert division to multiplication, the denominator ratio becomes opposite. So 5 threes are 15 upon 8. These are the other type of ratios that you must know, non-negotiable. Okay. Now can we go ahead? You can always take a screenshot or pause the video and keep writing. Very important table in the entire chapter of trigonometry is this, and I am going to tell you how to remember this table. First thing, write it in the line I have taught. Sine, cos, tan, cot, sec, cosec. Okay. Now remember the angles: 0 degree, 30, 45, 60, 90 degree. Okay. Now let's look at the answer of sine 0, cos 0, cos 30, cot 45. So you have to read this table in cross format. Sine 0 value will be here, cos 30 value will be here. Now let's jump on to how to remember this table. Okay, pay careful attention on how to remember this table. 0, 1, 0, n, 1, n. N is not defined, that is, answer does not come. So 0, 1, 0, n, 1, n. Okay. Now how to remember this 90 degree column? If you have 1 here, you will have 1 here. If you have 0 here, cross it 0. If you have n here, write n here. If you have 0, cross 0. N, cross it right here. 1, cross it right here. So now you are set with 0 degree. So how do you read this table? If suppose someone asks you what is the value of sec 90? Sec 90. How will you do it? Sec 90, which is not defined. If someone asks you the value of cos 0, cos 0 value is 1. This is how you read the table. Now let's look at how the other values in the table are coming. How do you remember these values? Now, sine values you have to remember, cos values you will automatically remember. Here you have 1 upon 2. Here you have 1 upon root 2. And here you have root 3 upon 2. You have to remember only the first line. Okay. Now, what will I do is, for cos, I will write root 3 upon 2 here. What am I doing? Crossing. I am crossing. Then again I will cross 1 upon 2 here. And this remains same. Wow, great. Now, what I will do is, for tan, here you have 1. I will write 1 upon. Here you have root 3. So I will write root 3. Just look at the numerator. You have here 1. You have in the numerator 1. So you will have 1 here. Here you have root 3. And in the numerator you have upon 1. Upon 1 doesn't make a difference. 2 upon 1 is 2 only. 3 upon 1 is 3 only. So root 3 upon 1 will be root 3 only. So that is why I am not writing it. Okay. So we will revise this at the end. Again, as I told you, you don't need to remember. Cross. Cross again. Root 3. Cross again. 1 upon root 3. And this remains the same. Now students, if you remember, I had taught you previously. If you remember this, sine, cos, tan, cot, sec, cosec. If you remember this, I had told you reverse of sine is cosec. Reverse of cos is sec. So go to cos and reverse it. Go to cos and reverse it. So here you have root 3 upon 2. You will have 2 upon root 3. Here you have 1 upon root 2. So you will have here root 2 upon 1. Which is nothing but root 2 only. Upon 1 does not make a difference anytime. And go here 1 upon 2. So here it will be 2 upon 1. Right? 2 upon 1 is 2 only. So I am not writing upon 1. Again cross 2. 2 upon root 3. And middle values remain the same. Okay. This is the basic structure of your trigonometric table. Now let's just quickly revise it again. Now I'm going to go super fast because I have already revised. 0, 1, 0, n, 1, n. Then what do you do? Cross. 0 this side, 1 this side. N here, 0 cross here, n cross here, 1 cross here. Now I remember the values. 1 upon 2, 1 upon root 2, root 3 upon 2. Then I cross. Middle values remain the same. I cross again. Now, what do? I just look at the numerators. In the numerator, I have 1 here. So I write 1. Then I write upon. In the numerator, I have root 3 here. Again, I look at the numerators. Here I have 1. Here I have 1. 1 upon 1 is 1. Here in the numerator, I have root 3. And here I have upon 1. So I am not writing. Root 3 cross here. 1 upon root 3 cross here. 1 remains 1. Now, Cos and sec are reverse. So whatever is there in cos, reverse and write in sec. Root 3 upon 2 becomes 2 upon root 3. 1 upon root 2 becomes root 2 upon 1. 1 upon 2 becomes 2 upon 1. Again cross. You have to write this table at least 2 to 3 times in order to remember it forever. Okay, so go home and pause the video and write this table at least 2 to 3 times and remember how you are writing it. It's not that you have written once and you have forgotten. You will have to repeatedly keep practicing the table. Now let's look at what I call as complementary angles. Very simple. Again, remember the sequence: sine, cos, tan, cot, sec, cosec. I am in this video telling you how to remember each and every formula that you're going to come across. Everywhere write 90 minus theta, 90 degree minus theta. Everywhere write the same thing. Everywhere write the same thing. These are 6 formulae. 1, 2, 3, 4, 5, 6. Remember the sequence: sine, cos, tan, cot, sec, cosec. Now this value is cos theta. Simple. Sine, cos, cos, sine. This is tan, so answer is cot. Cot 90 minus theta is tan theta. These are the formula. I am just telling you how to remember them. Here you have cosec, so you will get sec. Simple. I was just telling you how to remember the formula of complementary angle. Now let's look at another thing which is called as trigonometric identities. There are 3 trigonometric identities: 1, 2 and 3. You have to remember them all by heart. Okay. What is the identity? First identity is sine square theta plus cos square theta is equal to 1. This is your first identity. Second identity is tan square theta plus 1 is equal to sec square theta. Okay. Third identity is tan. So what remains? It's cot square theta plus 1. So you have these 3 identities which you have to remember by heart. Sine square theta plus cos square theta is equal to 1. Tan square theta plus 1 is equal to sec square theta. Cot square theta plus 1 is equal to cosec square theta. Now another entity that you got to remember is angle of elevation. What is angle of elevation? When you raise your head above to see something above is called as angle of elevation. What is called as angle of depression? What is the meaning when I say angle of depression? When you have to look down, when you have to look down to see something. For example, angle of elevation is some airplane is flying. Some airplane is flying and you have to look upward. Then it is called as angle of elevation. But if you are on the 7th floor of the building, 10th floor of the building and you're looking down, then it is angle of depression. Students, let's look at an example with which you are going to get 100% clarity on what is angle of depression, what is angle of elevation, how to use trigonometry in word problems. Okay, I will show it to you with an example. So first thing, I'm going to draw a triangle because I know in trigonometry we make use of right angle triangles. So I'm drawing a right angle triangle. Okay, now I'm reading a question. A ladder is 15-meter long. Okay, a ladder is 15-meter long, just reaches the top of the vertical wall. So if I give you a visual representation, he's telling me there is a wall. Okay, there is a wall. There is a wall. And on that wall, I have to climb using a ladder. Okay, I have to climb using a ladder. This is a wall and this is the ladder. Okay, so I have just drawn it in a well triangle platform. So this is your wall and this is your ladder. Ladder is how much? 15 meter. So this is 15. Well and good. If the ladder makes an angle of 60 degree with the wall, ladder makes an angle with what? Wall. So 60 will come here. Understood why 60 I have written here? Because ladder is making an angle with the wall. So ladder with the wall. Only this angle remains. So I have written 60 here. This is 90. This is 60. So always when you have 90, 60, the remaining is always 30. Similarly, if you would have had 30, 60, remaining would be 90. So it's a couple, it's a pair, 30, 60, 90. Whenever one is missing, the other you will get it as answer. For example, in the question, 30, 60 was there. So the third angle would have automatically come as 90. So 30, 60, 90 is a pair. 30 was not given in the question. Only 90 and 60 was given in the question. 30 I found out. How 30? If you want to know the logic, you can also go back to your previous chapters in your previous years that all angles of a triangle are 180 degree. So angle A plus angle B plus angle C is 180 degree. Angle A, B, C 180 degree. A was, I don't know what was A. B was 90. C was 60. So A plus 90 plus 60, 150 is equal to 180. A is equal to 180 plus 150 goes there, becomes minus. So A becomes 30. But if you don't want to do all this, you can always, if you don't want to do all this, always remember 30, 60, 90 is a pair. Okay. Now you found out that A is 30. Very good. Now I am just erasing this part. This was just for your understanding. Now what is the question? Calculate the height of the wall. So you have to calculate BC. BC is the height of the wall, right? You have to calculate the height of the wall. Okay. Let's make use of the formula. You know only one side and you know all the angles. So let's look at the formula of sine theta maybe. Sine theta formula is what? OH, right? So let me look at this sine A. Students in the question, look and tell me what is the opposite side of A? Opposite side of A, it is BC. What is H? Opposite side of 90 degree. H is how much? 15. Right? And what is the value of A? Angle A is 30 degree. Angle A is 30 degree is equal to BC upon 15. Now comes your table. Now you will see how you use the table. Now let's go back to table. I want to find the value of sine 30. So let's go back to the table. Sine 30. Sine 30 is how much? Half. So now let's go back to the question. Sine 30 is half is equal to BC upon 15. So what I want to find is BC. So let's isolate BC. 15 and divide goes that side, becomes multiplied. So BC is 15 upon 2. Okay. So I will keep the entire question on the board. If anyone wants to take a screenshot, can take a screenshot. I have explained you the concept in detail with a lot of examples and memory tricks. I hope you like this lecture. I will come again with another concept lecture. Stay tuned. Bye bye and keep practicing.